Hey everyone, welcome to Philip in the Cloud. It is me, Philip, and I am going to be talking about a new feature in Ibis that I'm pretty excited about called Unnest. Um, it's a feature that allows you to deal with um, nested JSON and arrays and structs and maps and so forth in a way that's friendly and easy to use. And in this video, I'm going to be using the Snowflake backend, which is new as of version 4.0. And you can, as always, check things out at ibis-project.org for more information. So let's get started. So I'm going to import Ibis. I'm going to pull the Snowflake connection URL from an environment variable. So I'm going to need the environ dictionary available in the OS module. And then I'm going to call ibis.connect, which this URL kind of looks something like this, Snowflake, and then a bunch of other junk there. So now we're connected to Snowflake, presumably. We should be able to call list tables, which of course there's a bunch of junk in there. And what I actually want to do is kind of connect to um, a database that let's see if I can get to it. Um, I have this set up in a demo database, so I'm going to actually need to replace do some string hacking. And I've got something in my user. Let's see, it's in the Ibis testing slash Voltron data Philip. And I want to replace that with demos. Of course, we have a demos schema, New York Times. Let's see if that actually works. Cool. So it didn't barf at us. So that's great. Cool. We've got one table going on here. And I specifically use this data set to test Unnest implementations because it tends to kind of run them through the ringer. And this is a data set that I collected from the New York Times during the 2020 election. I was hitting their JSON API and just kind of writing everything to disk and kind of doing a bit of uh, like streaming analytics on it using just kind of command line tools. And so I have that stored like in a cloud bucket, and I uploaded some of it to Snowflake. So let's pull that table out. Let's turn on interactive mode so that we get a flavor for what's actually happening here. Now let's just take a look at this schema. And you can see there's two fields, data and meta. And it's kind of an unassuming schema, but as we'll see in a second, the data are not to be trifled with, as it were. So let's just look at meta right now. Cool. So Ibis is perfectly capable of handling columns that are typed JSON, which is effectively a column that you know is valid JSON, but you don't really know anything else about it. Here it looks like our data have a fairly regular structure. They're a JSON object with three fields, maybe more, timestamp, track, and version. And in Ibis, you can't really do too many useful things with JSON objects. Um, they have two primary modes, and you can kind of see it's already hinting at me from the IPython completion, but you can extract columns, okay, or extract fields of an object, sorry, and then I'll turn that into a column. And JSON is kind of kind of a poisonous data type. Once you're in JSON, like you kind of stay in JSON, and that's because there's just a lack of type information there. Um, but of course, the other operation you can do with JSON is you can cast it to other things. So in this case, I'm just going to assume that everything's a timestamp, and using Ibis's cast API, of course, we can cast that to a timestamp, and we've got proper timestamps, right? So and then if we call execute, we get back a series. We can look at that. It's kind of big, and you can see at the bottom D type, date times 64 nanoseconds. So we did get back kind of a proper timestamp type now. And let's go back to this. So now we're looking at the meta field again. And we know, we can kind of do the same thing with other fields. We've already seen kind of the example. Of course, we can handle dates too. Let's just show that for good measure. cool, we've got a proper date column. And now you can start to use kind of the proper Ibis API, like what's the day, what's the year, that sort of thing, kind of these, the usual things. And Ibis is kind of aware of what you're casting to, and so it can handle kind of making the API really nice. What's really kind of an interesting feature here is that even though we have meta and we only know it's a JSON blob, you can actually cast a subset of fields to more strict types. You could, for example, say this is a struct with one field of type date, and now if you look at the type, and then you look at the names, I think this should work. We've got the track field in there, right? Which kind of means we can do track on there and see what that is. And Ibis kind of took care of casting the subfield and then giving you enough type information to pluck out that track field. So this is kind of a good intro to the simple cases of JSON where you might have just one level of object embedded in a data set. Where this functionality really shines is in the case where you just have like some super gnarly data where it's like maybe it's like an object, but then there's like fields, and then the fields are some are arrays. Those arrays are actually arrays of objects, which themselves contain other arrays and other objects, and it's just kind of this recursive mess of JSON junk. And this plays actually pretty nicely with Snowflake's data model, which doesn't have typed arrays or typed structs or maps really, but what it does have is that it has kind of, I guess, what I would call like a top level array or a top level map or a top level struct. And so you know something's an array, but you don't know what the element type of that array is. And you know something is an object, which means it's got keys and values. So you know that it's basically a map of kind of string to JSON, but you don't know anything else. And this actually makes dealing with crappy JSON very easy, which is pretty nice. So I'm just going to repr t.data, which is the other JSON field, and you can kind of see it's already starting to look pretty nasty. We've got rows where it's an object that's got live updates, and that's an array of other objects. There may be arbitrary many fields here, both in the array and in the top level object. But of course, we can pluck out live updates here, and looks like I'm kind of giving everything away here. So we got the live updates field. We know this is JSON, and let's say we just want to like sort of treat it as like a proper array. Like right now, Ibis is kind of just showing it to us as a string, and you can kind of give partial types here. You can say, okay, I'm going to assume it's an array of JSON, and now we've sort of got a proper array. And Ibis is pretty careful about not unfurling objects that are huge, and you can see here that one single row of this field has 658 or plus 2, so 660 elements. So that's pretty big, and if there are things inside of that are huge, then it will also it would also repr those, but it doesn't. So that's really nice, and that's why it kind of looks more compact here. And of course, we have an array now, so we've got get item, so we can just say, hey, give me the 0th element. And we can see from the brackets that we know it's an object, right? And so now we've got an array. We've taken out the first element of that array of JSON. So this kind of looks like it could be a struct, a JSON object, and we don't really know too much about what the fields are. And let's say we just wanted to look at what the keys are. What keys do I have available here? So the first thing you're going to want to do is kind of properly unnest that, right? And that's going to take every element of that array and flatten it into a table, and then kind of concatenate, do the same thing for every row, and then kind of concatenate it into a single column. And you can already see there's all sorts of like variation. We've got author, author, author for the first field, then we've got call type, author. Like it's just kind of a mess of JSON junk. The next thing we probably want to do is just kind of look at is like treat this each object as like just a map, right? Because I want to be able to get the keys out. I don't know what the keys are, so I can't really cast it to a struct, although from before we could subset on the ones that we care about. But you can, again, Ibis is like very flexible here in that it lets you say, okay, I don't know what the value types are. Again, it could be strings, arrays, nulls, other objects, whatever. But I do know, or I'm going to make the assumption that the map key or the object keys are strings. And you'll see that it kind of gives you a bit more information here. We're getting a little bit deeper repr. But maps have a method called keys, just like Python dictionaries, that lets you get out an array of keys for each object. And so now we've got this array. Now, one little bit here that can potentially be a pitfall here with Unnest, as you can see that I'm using here, is that you can't really easily chain it. And that's because Unnest is like a cardinality cardinality changing operation. So when I say Unnest, if I want to then do another Unnest on that, to give it an unambiguous meaning, I need to actually create basically a SQL select statement. And the way that you do that in Ibis is with t.select. So I'm just going to call this live update, or I'm just going to call this LU keys for live update keys. And then I'm going to make a new variable TT, or I'm just going to call this, TT. And it executes instantly because Ibis is deferred, which is really nice. And then again, we can just repr that and we'll see the whole thing. And now we've got an array of strings, okay, which is pretty neat. And of course, we can call unnest on that. Not on the table, obviously, you got to call it on the column. It's a column level operation, so we can do that. And now we actually have a list of all of the keys of that first of all the keys in the row in the data set for the live updates object arrays. But these are probably not unique, so let's just count them and make them unique. Call value counts. Boom. Now we see like this is basically the total number of elements of those arrays like totally unfurled, and so we've got author, headshot, etc. and all the keys there. And if you want to get that back as a data frame, df, you can call execute, and now we've got that back. So that's pretty fun. What else can you do with this? Well, like I said, we casted our object to array of JSON, right? And let's go back to live updates and get a better view of the data. Let's say we just wanted to pull out the author field. Well, there's a couple ways you could go about that. You could say cast to array of JSON. You could say unnest, and then you could cast to a map of string, and then say author. And this has the effect of when you access the author field, it'll give you back the values as a JSON value. But if that key is not available, it will give you a null back. So let's run that. Cool. Now we've got these. They're JSON values. We want to assume they're kind of strings. Not kind of strings, they're definitely strings. So we're going to cast it to a string. Doesn't look any different except now you have the type information. And we should be able to do a value counts on that and get back kind of the number of occurrences of each of these authors. And of course, you can do order by ibis dot desc for descending count limit 5, and that gives you apparently the null author has a lot of of articles. That's hilarious. It's probably from a row that has nothing to do with the author row. but we can see these people have a good amount of articles here. Um, Sorry, it's not articles. It's probably just mentions or references to their work somewhere. Now, of course, this is just an Ibis expression executing on the Snowflake backend, and if you want to see what Ibis is sort of doing on your behalf, making things flexible and easy, you can call ibis.showSQL. Now, this is going to be fairly traumatizing for some people because the SQL here is pretty gnarly. Yeah, and it, Ibis also kind of generates names automatically, and it will use those in subsequent queries. And so there's subqueries and hacks and workarounds like Snowflake, not being able to deal with dropping nulls in its flatten operation. But for example, like you as the user don't have to think about, oh, well, I need to do join, lateral, flatten, and then use the special Snowflake syntax for input and then split. And if I want nulls, I have to do that. And then if I want to be kind of safe and say only unnest arrays and not arrays and objects and group by and all this stuff, Ibis is kind of taking care of that for you behind the scenes. That's really it for Unnest. Please try it out, get involved. We would love to hear from you, ibis-project.org. We're also at github.com/ibis-project/ibis. And we want to hear feedback about this. It's a feature that is going to be available on any backend that supports arrays, except for BigQuery right now. The BigQuery implementation is not yet done. But Trino, DuckDB, Postgres, ClickHouse, Snowflake, those are all supported at the moment. Thanks, everyone, and I will see everyone later.